This is the 2014 Leaving Cert Higher Level Paper 1, and we're looking at question number 1. Part A says the graph of a cubic function f of x cuts the x-axis at x equals minus 3, x equals minus 1, and x equals 2, and the y-axis at 0, minus 6, as shown. So here's the function f of x. We have our x-intercepts here, these three places, and the y-intercept at minus 6. Verify that f of x can be written as f of x equals x cubed plus 2x squared minus 5x minus 6. Okay, well, if x equals minus 3 is one of the x-intercepts, we can say that x plus 3 is a factor. If x equals minus 1 is one of the intercepts, we can see that x plus 1 is a factor. And if x equals 2 is an intercept, well then x minus 2 is a factor. So if it's minus 3, x plus 3, minus 1, x plus 1, 2, x minus 2, the sign is opposite. So we know that these three factors will give us the function. So we can say that f of x is the multiplication of these three factors. So if we do the first one, x times x is x squared, 3 by x is 3x, x times 1 is 1x, and 3 times 1 is 3. So the first two brackets multiply to give this, and we still have the x minus 2 at the end. So when we tidy this up, it gives us x squared plus 4x, 3x and the 1x, plus 3 by the x minus 2. So now we're going to multiply the x by x squared, gives us x cubed, x by 4x is 4x squared, and x times 3 is 3x. Then the minus 2 by x squared is minus 2x squared. Minus 2 by 4x is minus 8x. And finally, minus 2 times the 3 is minus 6. And if we tidy this up, we can put the 4x squared and the minus 2x squared together, and the 3x and the minus 8x together. So that's going to give us x cubed. 4x squared minus 2x squared is 2x squared. 3x minus 8x is minus 5x, and then our minus 6 at the end. And that is the function that we were asked to verify that it can be written as. So that's the end of part A. Part B1 says the graph of the function g of x equals minus 2x minus 6 intersects the graph of the function f of x above. Let f of x equals g of x and solve the resulting equation to find the coordinates of the points where the graphs of f of x and g of x intersect. So the key thing here is this bit here. It says let f of x be equal to g of x. Okay, so we had f of x before was x, this one here, x cubed plus 2x squared minus 5x plus 6. So x cubed plus 2x squared minus 5x minus 6. And we're going to let that be equal to g of x, which is minus 2x minus 6. So again, just to be clear, we had f of x, which is this, and we're letting that equal to g of x, which is this. And we're asked to solve the resulting equation. So we're going to form an equation from this. I'm going to bring the minus 2x over here. It's going to become plus 2x, and it can be combined with the minus 5x. And the minus 6 I'm going to bring over here. It's going to become positive 6. So on the left I have x cubed plus 2x squared. 2x minus 5x is minus 3x. And minus 6 plus 6 is 0. So I'm left over on the right side with nothing, 0. Okay, so now I've got an equation that I need to solve. So it's not a quadratic, it's a cubic, but I can factorize x out of all of these terms. So that's what I'm going to do first. X factorized out of x cubed leaves x squared plus 2x minus 3. So factorizing x out leaves me with a quadratic in the brackets. So I'm going to factorize that quadratic into double brackets. So that's x and x. I want factors of minus 3 that will add or subtract to give positive 2. So that's going to be minus 3 and positive 1. Sorry, it's going to be positive 3 and minus 1. So positive 3 and negative 1. You could do a quadratic formula on this also, but this is a bit easier. So plus 3 by minus 1 gives minus 3, and 3 minus 1 gives positive 2. So we factorize correctly. So if this times this times this equals 0, well then we have to imagine what if each thing was 0. The only way that can happen is if one of these things here, one of these three factors is 0. So let's have a look at each one. If x is 0, well then x is 0. That's the first solution. If x plus 3, the first bracket here, if that was 0, that would mean that x was minus 3. And if x minus 1 was 0, that would mean that x was 1. So my three x coordinates are 0, minus 3, and 1. And we were asked to find the coordinates of the points where they intersect. So to find the coordinates of the points where they intersect, I can plug these x values into one of the two functions. I can plug them into the yellow or the green. The green looks a bit easier, so I'm just going to plug it in there. If I put x into g of x, so in other words, if I find g of 0, that gives me minus 2 times 0 minus 6, which is minus 6. If I do, so that gives me the point when x is 0, y is 6. So minus 6. That's one coordinate. Then I'm going to try g of minus 3. That's equal to minus 2 times minus 3 minus 6. And that's equal to minus 2 by minus 3 is 6. And 6 minus 6 is 0. So when I put in minus 3, I get out 0. So that's another coordinate where they intersect. And finally then I'm going to find g of 1. So that's minus 2 times 1 minus 6, which is minus 2 minus 6, which is minus 8. So the third coordinate, the intersection is 1 minus 8. So there are my three answers. My three answers there in blue. They're the three coordinates of the points where the graphs of f of x and g of x intersect. Okay, part 2 then. The last part says draw the graph of the function g of x equals minus 2x minus 6 on the diagram above. Okay, well if I found the points of intersection, I know that these points here are on g of x. So I can just plot two of these points and draw the graph from there. I know it's linear, I know it's a line because the highest power of x is 1. So I'm going to plot the points 0, minus 6, and minus 3, 0. So 0, minus 6, which will be here, and minus 3, 0, which would be there. So I'm just going to join those points up. And then extend the line all the way out to the end of the graph. And I'm going to label it. That's the point. If that's f of x, then this is g of x. So that's what I was asked to do. And that's the end of question 1.